Okay guys, so today we're going to be doing Leetcode 2831. Find the longest equal subarray. So I'm going to give you guys a moment to pause and just read the problem statement. So yeah, you have the first test case. So we'll just go over the first test case. So the first test case says we have this array 1 3 2 3 1 3, and we have our k value, which is equal to 3. Now it's saying if we delete th this value and this value, the optimal new answer will be, or the new array will be this, and then from there our best answer will be this subarray right here. Now for the second test case, we have an array that looks like this: 1 1 2 2 1 1 with k equal to 2. If we delete these two values, then we'll get a subarray that looks like this. We'll get a new array that actually looks like this: 1 1 1 1, and our optimal answer will be 4, because this subarray has all elements that are matching, right? Now, the naive approach would probably try to brute force this by finding every possible subarray, and then from every possible subarray seeing the maximum element size, or the maximum element, and then trying to remove the finding the maximum element count, and then trying to remove every other value that does not correspond to the maximum value count, which I believe would get you n squared, because you would try to go from this one, and then from this one you try to create every possible subarray, and then you try to find the maximum count of each number within that given subarray, and then you would take the number that has the maximum count. So for example, if we were given 1 1 2 1 3 4 5, and in this n squared solution we're looking at this subarray at the moment, starting with I from here and then our j being here, given that we have a nested for loop where the outer for loop has a local variable I, and the inner for loop has a local variable of j. So then we would obviously find the count of these values. We'd find the count of these values, and then what we would do is then we would take the maximum count. So since 1 has a value of, there's 3 ones, and there's 1 2, we would consider the way we would get the optimal answer for this subarray is by just deleting the 2, and then we'd have these ones. And then you obviously repeat this solution for every possible subarray, which would then give you the n squared solution, right? Now, the n squared is not optimal. You have to do something that's better than n squared, right? And if you realize something about this problem, it kind of spits out sliding window to you. So the sliding window, and this problem is very similar to many sliding window problems, and let's just go over the sliding window solution right now. So yeah, for the sliding window solution, let me write up a test case. Let's say we have this test case: 1 1 2 1 3 4, and let's say k is equal to 1, right? If k is equal to 1, uh, I mean, just by looking at it, we can immediately tell that our answer is going to be this, right? Our answer is going to be 3, or it's going to be 2. Um, or, yeah, my bad. Let's make it something where we're actually having to delete a number. So yeah, let's try to add, uh, let's try to make our k a bit, uh, my bad. It would be this. It would be this. This would be the value. So our k would be 3. So since our k is 3, we would then have to find this window, right? So since we find this, so the way we find this window is by doing sliding window, right? So what the premise of sliding window is to have a valid window, and then once you come across an element that makes your window invalid, what you're then going to do is then just adjust it from the left. So we'll go through an example right now, and I'll show you guys what I'm talking about. So let's go through this example. 1, 1, 2, 1, 3, 4. So and our k is equal to 1, right? So we start here. We're going to have 2 pointers pointing to here. So we're going to start here, and we're going to have this the start, and the other one be called the end. So we're going to move our end pointer. So we start at this first index, index 0. We start at index 0. So what we're going to do is at every time we move the end pointer, what we're going to do is we're going to take that new element that we just took into our window. We're going to add it to a count for that specific element, and then we're going to then find the maximum element within our window. So what I mean by that is every time we add a new we're just keeping count. Every time we move the end pointer, we're just keeping count of the new elements that go into our window. So our first element that we encounter is 1. I'm going to put this in a different color. So I'm going to put element and then count, just to show you guys what I'm talking about. Let me just move this here. Okay, so element. So our element is 1, and it has a count of 1. And our maximum value within our maximum count, or our element with the maximum count within this window is just 1. So far the most optimal answer we've encountered so far is a window that only includes this, and we don't have to delete anything, and our answer is 1. Now we keep moving this forward. So now our end pointer is here, and we've encountered another one. So what we're going to do is we're going to change our count and make it 2. Since we've now made it 2, we're going to then check if we're violating the our k rule, which is are we deleting any more values than k count, right? And how do we check that? Well, we check again let me write this somewhere. Max count minus my bad. It's let me rewrite that. That's the wrong way. size of window minus max count. That will give us the number of deletions. And if this number of deletions is bigger than k, then we know for a fact we've violated the rule. So we're at our end pointer is here. Our max element count is related to the element 1 because element 1 has a count of 2, and our size of our window is 2, so the number of deletions we're going to do is 0. So at this point we're going to be doing 2 minus 2 equals 0. So this rule is not violated. Keep moving it forward. We're here now. E is equal to 2. So now we have another element that we're going to be adding into our counter. So we have the element 2 and it has a count of 1. Now let's reuse this formula again. We have, let me just erase this. We have a window size of 3, a maximum element count of 2, which is the element 1, and that gives us 1. So we're gonna have we're gonna have 1 deletion to get the optimal answer for this window. Now that does not violate the k rule because we have 1 deletion at most. So this is one possible answer, and possible answer. We're gonna keep this possible answer here. This is also another possible answer. Let's make it a different color. Let's make it blue. So remember when we were at 0, it was 1. When we were at 1, it was 2. And now we're at index 2, it's still 2. Now we move to index. Now we move to index 3. So we have E3, and we still have not violated our k rule. So we're not going to move our pointer from the at the back. So again, size of our window is what? 4. Max count. Oh, and I forgot to change the max count. My bad. Max count is 3 because we just added in a new one. So we get 3, and our total number of deletions is 1. So again, we're not violating our k rule. Keep moving forward. And my bad. Okay, before we move forward, we're also going to update our answer. So it is no longer 2, now it's 3. Because if we delete this 2, we're going to get 3, right? Now moving forward, E4, and we get that size of window, which is 5, and the max count. And again, we need to update our max count. We don't need to update our max count because it's still the same element. We have within this given window, 1 is the element with the maximum count, and we should add to our element count, we should add a 3 as well. Let me move that. and we get 3. And then here, 5 minus, what is the max count? Max count is 3. Now we get 2. Okay, now we violated the K rule. Now we have 2 deletions that we have to do to get the best answer for this given subarray. And in order for us to make our window correct again, we have to push from the back. We have to push from the back. So let's just say we push by 1. We push by 1. So we're gonna push S0 by 1 and go here, S1. And when we do push up S1, we're gonna update our count. We're gonna update our count to 2. Because now we've pushed out that that one, right? So yeah, now we're going to keep moving forward. E4, E5, and our max count is, and we also add a we add the 4 to our count. We get 4 1, and we get size of window, which is no longer, it's now this that we're looking at, and we get 5 minus max count is what? Max count is still 2. Now we get 3 deletions. Now we move our window up by 1 because we violated the K rule, and we go here, S2. But now we've ended the traversal, and our best answer is what? It's 3. So yeah, so this is the solution. Now we're going to the time complexity of the solution is O of n. Now before I actually show you guys the code on Leetcode, I'm gonna bring the Leetcode onto this whiteboard and kind of break it down a bit more, because there's a bit of confusing moving parts. Okay guys, so here we have the code. So first thing, we're going to have a dictionary or a hash table that keeps track of the count of each element within the window we're looking at. Then we have a variable called max number. What max number does is it sort of tells us what the possible answer is, and it tells us the count of the most frequent element within our window. And then we also have start, which represents the S pointer from this previous example that we did here. And then we have this local variable I within the for loop, which represents the E variable. So we're going to traverse through the whole numbers array, and for each time we index or we move I, we're going to then take that new element that we've just added to our window and add its count. So that's what you see us do here in this line right here, dictionary nums I plus equals to 1. Now we also have a another line right beneath it where we update the max. So if you look here, we do max num dictionary nums I. So we're seeing, hey, this number that we just added into our window, does it give us a new max number for our window, or max count for our window. If it does, then we update it. If it doesn't, then we don't. So then after that, what we then do is we check, hey, is, sorry for the background noise, guys. We then check, hey, is I minus start plus 1 minus max num. We're essentially checking here this formula. Is the size of the window minus max count. What is the number of deletions? What exactly is the number of deletions we'd have to do on the given subarray that we're looking at to get the best answer? And if that number of deletions is greater than k, if it's greater than k, then we cannot use that window. And on top of that, we cannot we cannot use that window, and on top of that we'd have to adjust our window because now our window is invalid. So now what we do is we move up our start variable by 1, and then we also update the element that leaves the window by accessing our dictionary and decrementing the count of the element at start by 1. So now this is where the confusing part comes in. You know, usually with sliding window, what people tend to see is this. Instead of this if statement, you know, usually you put a while, and a while statement will work as well. Reason why we only move it up by 1 is because we're trying to track the longest subarray, right? Or the longest possible window right? So let's just say we have a bunch of numbers. It doesn't. I'm not gonna put in a realistic example right now, but let's just say we have this window that we're looking at. Before we add in, if we assume this window to be valid, before we add in this element, this element can either make the number of deletions we have go up. It can either make our number of deletions go up, or our max count go up. Right? Now if our max count goes up, and remember this, if we're assuming this window to be valid, that's all fine and good. We don't have to really do anything. But if the max number of deletions goes up and it violates the rule K, the K rule, then we're going to have to do something about it, right? We're going to have to adjust the window. Now the reason why moving it up by 1 works is because remember, if we assume this previous window to be correct, and if that previous window is correct, that means that previous valid window was our best answer. Now it takes some time to kind of convince yourself of that. That previous window we had was our best answer. Because remember, we're only either building on our previous answer, or we're moving on. We're moving on and moving the window till we get something that's equal or larger. Right? So if we get something that's equal, nothing happens. But if we get something that's larger, we keep increasing it. And we keep increasing it until it becomes invalid. And then once it becomes invalid, we then repeat the process. We keep moving our window till we get something that's equal or larger. So that means this previous window here, this previous valid window, was either a larger window than the one before it, or it was equal. Either case, it's it's the best answer we have, right? So if we just decrease it by 1, because if we add in this new part and we if we add in this new part and we get an inval we get that k the k rule is violated, just moving it up by 1 will suffice, because all we're trying to do is now find the next larger window. We don't really have to shrink all the way down. We don't have to shrink all the way down to find the next largest window. We can just shrink by 1. But what we have to do when we do shrink is keep track of the number of elements within our window. That is crucial. So when we do find our max number of deletions goes up, causing us to violate the rule K, we're just gonna shrink our window by 1 from the left, and doing so it will suffice and will still help us to find the optimal answer. Because remember, if we're assuming that the previous window is again the best answer, then that means we have to continue that motion of we're gonna keep finding another window that has something that's equal or something that's larger. So if that doesn't make sense, just take some time to go through this code and convince yourself. Now, a while loop does still work. It will work. Don't get me wrong on that. It will work. But the if you put in a while loop, it's the same thing as putting in an if statement. Why? Because if you look the way the condition is set, if the size of the window is if the size of the window minus the maximum count is greater than k, then we keep shrinking. But since we're only moving the size of the window and we're not updating our max count, then there's no need. Then we're not gonna really decrease our window from the left by more than 1, because once we move it up by 1, then this k rule is met again. But then now the question comes, hey, how come we don't update our max? Why don't we update our max as we're moving from the left? Again, the reason why we're not updating our max as we're moving from the left, because it does not matter. It's not really important. We don't care that letter has left the or that element has left the window. We just care about us having max num being either the previous valid valid best answer or the current best answer. Regardless of the case, we just max num will always hold the best answer we had, and again, it will also it will tell us the max count. So remember how I said, if we're in this a constant process of, hey, we found a window, we found a valid window. Now, and we're always gonna start off with a valid window no matter what. Why? Because k is at least 1. If k is at least 1 and the smallest window we can have, smallest valid window we can have is a size 1. K is equal to 1, and we have a window of size 1. We don't delete any elements, right? So that's our we automatically start off with a valid window. So when we start off with a valid window, we can either then find something that's bigger or something that's equivalent. And if we find something that's bigger, no matter what, our max num will be updated, because we're moving our end pointer in such a way and updating it and updating the max num so that we have the valid maximum number within our window. So max num it's always going to be related to the maximum value of the last valid window. So yeah, now I'm just gonna run this code, run, submit, and yeah, as you guys can see, we pass. So yeah, if you guys have any questions, please list them down in the comment section. But yeah, have a nice day and see you guys next time.